Problem statement. Somebody gives you this data. This data is given to you. And somewhere among this number, somewhere in this data, there is a number that do not belong in this set. Your task is to find that number, find that weird value that is sitting silently in there and that do not belong there. This session is all about finding that number. By the way, the answer is 60. So in this session, we are going to be talking about the need for quartile, what's a quartile, and how do we even calculate quartiles. So why do quartiles they matter? Well, they break your data into manageable chunks. So let's say this is the data. You want to break it into chunks. So this is a small piece of data. In reality, you're going to have thousands and thousands of rows or thousands of records, and you have to break them into manageable chunks. So what quartiles they do, they divide your data into four equal parts. And for that, you need these values, Q1, Q2, and Q3. The property of your cell of your value Q1 is that 25% of your data is going to be lying below Q1. So 25% of your data is going to be lying below Q1. 25% of your data is going to be lying between the value Q1 and Q2. So 25% of your data is going to be lying right there. And likewise, 25% of your data is going to be lying between Q2 and Q3, and rest of the other data, which is 25%, is going to be lying above Q3. So these is your quartiles. So they kind of give you a structured view of your distribution. So rather than just looking at all the numbers at once, if you look at all the numbers at once, they would not make sense. But once you know your Q1, Q2, Q3, it kind of helps you understand how your data is distributed. So quartiles, they help you show the spread of your data. The range can be misleading. Okay, if you work with the range, it can be misleading because if there are some outliers, range will actually skew your result. Quartiles, on the other hand, they focus on the middle portion of your data where most of your data lies. So let's take this example right here. So let's say you have the test scores of the student in a class, and only one student right there, only one student scored 0, which is this guy right here. Rest of the students, they scored between 70 and 90. As you can see, rest of the students scored between 70 and 90. So the range will exaggerate. It will actually say that, hey, your student scored between 0 to 90. Well, that's not true. If you think about it, most of my students, just by looking at the data, you can tell that most of my students, they scored between 70 to 90. And this is where your quartile can actually help you determine that. Now, they also help you spot outliers. So by calculating your interquartile range, or your IQR, another name for that is IQR, which is equal to Q3 minus Q1, we can actually set up boundaries to detect unusual values. So anytime when your values are lying outside the boundaries, we can actually find that. So let's look at this example right here. Okay, somewhere over here is an outlier. Well, you can tell just by looking at this that most of my values are 99, 89, 88, 89. You see that? And then all of a sudden you see this value 1903 and 2 and 3. These are my outlier value. So your quartiles, okay, your quartiles, they help you identify your outlier values. They're useful in finances. Sometimes you have to detect fraud. It can also be used for in medicines, for example, abnormal lab results, and also in businesses. For example, you want to detect odd customer behavior. So quartiles also feed into visualization, specifically box plot. I'm sure some of you must have worked at box and whisker plot at some point. So they actually use your quartiles to summarize the entire data set visually, and they also help you identify your outlier points. So this is an example of a box plot right here. So in this case, you can see my Q1 is going to be here, my Q2 is there, my Q3 is here. These points, these whiskers right here, these are my upper and lower boundary. My lower boundary, my upper boundary. Now, quartiles, they're also robust to your skewed data. So mean, if you remember, mean basically, if you put some extreme value, then your mean can change. On the other hand, your quartiles, okay, they would not change. They are basically resistance to your outlier. So in this data right here, you can see 2 and 3 and 1903. These values are kind of like extreme values, right? Most of your values are between 99, 89, 88. So you can see most of your values are in the between the range of 80 to 90. But because of the presence of these values, these two values, your mean is going to change, but your quartile is not going to change. Your quartile values will remain the same. So in short, quartiles, they matter because they tell us the center of the data, they tell us how the data is spread, and they also tell you where most of your values lies and if something looks unusual. So how do you find Q1, Q2, Q3 and your IQR? Well, step one, arrange your data. Okay. First, you want to make sure that you arrange your data in an ascending order from smallest to largest. So quartiles, they only make sense when your data is sorted. So let's say this is the data given to you. This could be that, let's say, a temperature in a city. So after sorting, this is how your data will look like. That's your step one. Step two, find Q2, your median for the entire data set. The middle value, okay, that splits the data into two equal half, that is going to be your Q2 right here. This is going to be your Q2. So if the number of data points is odd, okay, if you have odd number of points, then your median is going to be the middle value. And on the other hand, if it's an even number, let's say you have an even number of data points, then your median is going to be the average of the middle value. So let's take a look at an example. This is the example that I'm working with right here. So in this case, I have 13 numbers. I have odd number. So in this case, my middle value is 6 right here, 6. So this is my middle number right here. So this from here to here, this is my lower half, okay? And this is my upper half. And this one right here is my Q2. This Q2 is my 6 right here. So 50% of my data lies in this area and 50% of my data is going to be in this place. Step 3. Now I'm going to find Q1. Q1 is the lower quartile. Q1 is the median of the lower half of your data. So this is my lower half. Okay, this is my lower half, and this right here is going to be my upper half. So this one right here is my lower half, and you have to find my median for this. That median is going to be my Q1. So my lower half is -3, -2, 1, 3, 4, 5. Find the median of that. In this case, I have even number of points. So you take the average of the middle two numbers. So this is my middle two number. And I'm taking the average of these two numbers. The answer is 2. So my Q1 is 2. This is the median of the lower half. Interpretation, 25% of my data is below 2. That's what you mean. That if my Q1 is 2, right, this is 2, that means 25% of my data is below Q1. Step 4. Now we're going to find our Q3, which is the upper quartile. So Q3 is the median of the upper half. It is the median on this area, this place right here. Okay, that's where you're going to look for your Q3. Another name for Q3 is 75th percentile. Another name for Q1 is 25th percentile. This is also called 25th percentile, and this is also this another name for that is 75th percentile. Okay, so in upper half, which is this right here, okay, this is my upper half, you find your median. But in this case, my middle values are 12 and 15, right there. So you find the average of these two numbers. The answer is 13.5. So my Q3, which is this value right here, is 13.5. And that is my Q3, the median of the upper half. So that means 75% of my data, it lies below 13.5. That's what it means. All right, step 5 now. Now we're going to find our interquartile range. So IQR actually measures the spread of your middle 50% of your data. So the formula for IQR is Q3 minus Q1. We already calculated our Q3, that was 13.5, and we already know our Q1, it is 2. So 13.5 minus 2 is 11.5. So I know my Q1, I know my Q2, I know my Q3, and now I know my IQR. So what does IQR means? It means that 50% of your data, right? If you look over here, my IQR is this value right here. So 25 plus 25 is 50. So 50% of my data values lies within an interval of 11.5 unit. That's what it means. So what exactly IQR tells us? It tells us this, that if you have a small IQR, your data is very tightly packed. Okay, there are basically less variability in your data. On the other hand, if you have a large IQR, your data is more spread out. Okay, that's what it's telling you. So it focuses on the middle part of your data. It ignores extreme value. So if you think about it, you see your IQR, the way you find your IQR, you used value Q3 and you used value Q1. You did not use these values at all. Okay, these values were irrelevant to find that. So in other words, it is ignoring these outliers. This is ignoring these extreme values. So in this case, it ignored -3, it ignored -2, it ignored 60, it ignored 20. You see, all these values were ignored. Okay, now let's try to look at a use case of your quartiles. Like how do we use Q1, Q2, Q3, and IQR? So values are considered to be outliers if they lie below this value, okay, below this value or above this value. So these are my upper threshold and lower threshold. This is my lower right here. This is my lower threshold. This is my upper threshold. And that's why, by the way, IQR is used in box plots to identify these outlier points, these unusual data points. So in above case, in the case that we just studied in this example right here, my lower boundary, okay, my lower threshold is going to be Q1 minus 1.5 times IQR. Well, substitute my values, I substitute all my values, and my lower boundary comes out to be minus 18.25. So my lower boundary is minus 18.25. That's my lower boundary right here, okay? Then likewise, I find my upper boundary. My upper boundary formula is right here, this one. So I'm using my formulas, I'm substituting all my values, Q3 plus 1.5 times IQR, and the answer comes out to be 33.75. So this is 33.75 right here. So any value that is not in the range of minus 18.25 and 33.75, any value that is not in between, they are your outliers. Well, just by looking at this right here, now you can tell that your outlier is 60, because 60 do not come in this range. It is an outlier.